Welcome to section 9.5, and in this video we are going to be solving quadratic equations by graphing. And so we've already been practicing graphing. We've been finding the axis of symmetry and the vertex and the y-intercept, and then also finding a couple more points that we could mirror across that axis of symmetry and then graph an equation or a function, parabolic function in all reality. But at this point in time, we're also going to find what's called a solution to what we are doing. And when we find these solutions, we will be playing around with what we've done in the past with factoring and things like that as well. So to start off with, the first concept of this entire chapter is that every function has a related equation. The last couple of days we've been playing with this formatting. F of x is equal to ax squared plus bx plus c, or we've seen this y is equal to all of this information, and we've been really used to that. Well, now we are replacing that y with a 0, and what we can actually say is that every function, every y equals equation, if we wanted to, we could find a solution by simply replacing the y with a 0. And if we were to write 0 is equal to ax squared plus bx plus c, it doesn't change our thought process so much, except for the fact that there's now a 0 there. That means we can solve for x. Because if we remember, a, b, and c are all values. They all have a value that's related to them, like 3 or 17 or a million or whatever, but they all have a value related to them. And now if we have the y out of the equation, we have one equation and we can solve for x, which is kind of cool. So throughout this particular chapter, actually for the rest of this entire chapter, we're going to be finding solutions. And solutions are very specific things. We can say solutions are essentially the zeros of a function. So essentially that is also the x-intercepts of the function. And you'll eventually hear one last term that they are called, and that is roots. So all of these things are the same. Solutions are zeros, they are the x-intercepts, and they are the roots. And all of these are the exact same thing. If we were to essentially take an equation such as y is equal, or take a function such as y equals 3x squared plus 5x minus 7, we can just substitute 0, actually I'll use a different color, 0 in for y, and we can find what x equals, and those are our solutions. So moving on from there, there's a few things that we can do to actually do this when we're graphing an function to be able to find its value, to find its solution. Our first step, we need to simply write the related function. We also need to then graph said function, which we know how to do with axis of symmetry, vertex, y-intercepts, and finding other points with the table. And step 3, we then need to find those roots. We need to find the zeros of that function. So we're going to go through this process with an example. So here's our example problem. We have 2x squared minus 2 is equal to 0. So when I say we need to write the related function, essentially we would write, instead of a 0 here, and we are only ever replacing a 0. If you don't see a 0 in that spot, we need to do a little bit of algebra before we get there. So we're going to just replace the 0 with a y, and everything else stays the same. So we'd say 2x squared minus 2 is equal to y. From there, we need to find the axis of symmetry, and in order to do that, we need to use that equation. I'm going to zoom in here a little bit so we can do this. We need to use that equation of negative b over 2a. So we have negative b over 2 times a. And now we have to identify our a and our b. Our a term, it looks like, is 2. I see a C term, which is a -2, and our B term, that term that goes along with our x, is actually not even there, so it's 0. So we have -0 over 2 times 2. So if we have -0 divided by 2 times 2, that's -0 divided by 4, which is actually still equal to 0, because 0 divided by a number is 0. So our axis of symmetry is actually our y-axis, which is kind of nice. That means our vertex lies on our y-axis, which means it's also going to be our y-intercept. So using all of this information, we could then put in 0 for our equation, which we know is going to get us our y-intercept of that vertex. So all of this, 2 times 0 squared, that's all going to be 0. And our -2 just remains, so our vertex is going to be 0, -2. So let's graph that, and I'm going to graph it in green over here. 0, -2 is our vertex. So that's kind of cool. We have our vertex graphed and our, axis of symmetry. The last little bit, we need to find the y-intercept, which is our vertex. We don't need to find that. Now we need to find a couple more points. So since we let's pick one side of our axis of symmetry. Let's pick a point, maybe 1, when x is equal to 1. What does everything equal to? So if x was equal to 1, we have 2 times 1 squared minus 2. 2 times 1 squared is equal to 0 times 2, or 2 times 1 squared is equal to 1 times 2 equals 2 minus 2, which is equal to 0. So at 1 it equals 0. Then our other equation that we can, or other point we can maybe find is x is equal to 2. So if 2 times 2 squared minus 2, that's what we're looking for. 2 squared equals 4 times 2 equals 8. Minus 2 is equal to 6, so we then have the other 0.26. So now we can graph these 2 points. So we have 1, 0, and 2, 6. And what's also neat is because it's the axis of symmetry, we also know that these points are reflected across that. We have -1, 0, and we have -2, 6, and so we can then finish graphing this by putting everything all together. And this is probably pretty pointy for a parabola, but that's as best I can do for this thing. So our zeros, if we are looking back at our original problem, our zeros were actually some of the points that we found, so we could actually say our zeros in this case are the following numbers. Our zeros are at -1, 0, and +1, 0. And they are points, they're solutions. They're essentially the point where this graph crosses the x-axis, and that these points cause our y to be 0. And that's why we know they're solutions. So let's do this a couple more times. We're going to speed up this process a little bit though. So graph this function, -x squared minus 4x minus 4 equals 0. So we need to write the related function, and that is going to be -x squared minus 4x minus 4 equals y, or f of x, either one. After that, we need to find the axis of symmetry, and so I'm going to zoom this forward and put that down. It'll magically appear in front of you. Okay, so I did a little bit of the work. We have -b over 2a, and I ended up getting -2 for our axis of symmetry, so that's x equals -2. We're going to graph that. So, oops, that's a bad color. I'm not going to use yellow. I'll use orange again. So at -2, we have our axis of symmetry. Finish this baby off. And then our vertex is also in there, so if I were to stick -2 back into our equation for all those x's, we should be able to find that. So we'd have -2 squared, and it's actually a -2 minus 4 times a -2 minus 4. So we end up getting -4 plus 8 minus 4 equals 0. So our vertex is actually hitting our x-axis right there. So there's our vertex. Our y-intercept we can figure out by essentially saying, okay, if all the x's were equal to 0, what remains? And that would be our y-intercept is at a -4. And that makes sense because our function is actually facing downwards based on this a term. And we know that's reflected across our y-axis, or our axis of symmetry. So let's find one more point, and actually that logical point might be maybe finding when x is equal to not -2, when x is equal to -1, what does everything else equal? And what we get there, if we actually put -1 in there, our resulting y is going to be actually I wrote a 4 in and that's not correct. I need to erase this. Y is equal to -1. And so when that's the case, y is equal to -1, and so I'm going to mark that, and that means also at -3 it equals -1, so we can then draw our parabola. And I'm always going to draw it with little arrows on the end because it goes on forever. So our zeros, in this case, where it crosses the x-axis, is at simply one point, and that is at -2, 0. That is our 0. And what we've said before, there's many solutions to equations, or you can find certain amount of solutions to equations. We can either find 2, 1, or 0 solutions. And if we have if we have one solution, it's the vertex is the thing that's touching the x-axis. If we have two solutions, that means it looks like the previous equation where that parabola actually goes through the x-axis twice, and then there's one situation where there's no solutions, and we're actually going to try one with no solutions. So let's see what that looks like. Now, I don't want you to get sidetracked with the fact that this current equation doesn't quite look the same. The very first thing we need to do is we need to write it in standard form so that way we can actually turn it into the related function. So that means we are going to have to subtract this 4x from that side, so we get x squared minus 4x plus 5 is equal to 0. So I just essentially subtracted 4x from this side and put it over on the left-hand side. So x squared minus 4x plus 5 is equal to 0, and then we can rewrite that related function as saying x squared minus 4x plus 5 is equal to y. Now we need to find the axis of symmetry, and we're going to be using our a terms and our b terms. And our a term in this case, a term is equal to 1, and our b term is equal to -4. So we're going to put that into the equation -b over 2a, and we end up getting a -4 times 2 times 1, which is equal to 4 over 2, or 2. So that is our current situation. And so we can then graph that at, oops, I used the wrong, well, it's the right color, but it went on the wrong line, and that's just going to be hard, and how it is. So we have a 2, and there is our axis of symmetry. Then we need to figure out our vertex. Our vertex is where the is crossing on that axis of symmetry, so we're going to put in 2 squared minus 4 times 2 plus 5, and from there we get 4 minus 8 plus 5 is equal to 4 minus 8 is a -4 plus 5 equals 1. So our vertex is at 2, 1. So that's kind of cool. 2, 1 means it is right about there is where it crosses that axis of symmetry. We need to find the y-intercept, and our y-intercept is when all those x's are equal to 0. So we have 0 squared minus 4 times 0 plus 5. What is remaining? All of this turns to 0, all of this turns to 0, so we just have a 5. So our y-intercept is at 5. I'm going to use a different color, 5. And we know that is reflected over on the other side of our axis of symmetry, so at 4, 5, there's another point. And actually already as I look at this, I am seeing that this is not even touching the x-axis. I know that because we have an a term that is positive, so this parabola is pointing up with its legs, and its vertex, its minimum, is at x, or is at y equals 1. So it's not even going to cross that x-axis. So there I can say already that there are no solutions, even without finishing the graph. However, we're going to find one more point so we can just practice and actually find those, or make sure that's right. So let's actually do, if x is equal to 1, what is y going to equal? So if we have 1 squared minus 4 times 1 plus 5, what do we end up getting? 1 squared is 1 minus 4 plus 5. So 1 minus 4 is negative 3 plus 5 is equal to 2. So when x is equal to 1, y is equal to 2. Let's graph that. There we go. And then there's going to be a corresponding point on the other side of that axis of symmetry. And that was a horrendous line that I just drew. Let's see if I can actually make that a little better. Here is our parabola that we can draw, and that was a little bad, but whatever. So this particular situation, it is not crossing the x-axis. X-axis equals does not cross. So because of that, there are no solutions, and that's pretty important. So I hope this helps for this particular chapter, or this particular section of chapter 9. Do the math homework and be sure to come to class with questions. Thank you so much. Bye.